Yeah, DevOps, to tag on to the previous speaker, DevOps and security. Is it a match made in heaven, or is it a forced marriage from hell that's doomed to fail? Or are security and speed compatible, or are they the opposite ends of the spectrum? To start this, I want to start with some interaction and some easy quizzes. There's quite a few of infrastructure people here, so this shouldn't be an easy one. And this is the warm-up. Who knows the acronym for this protocol? HTTP? Good. This is a warm-up question, so you don't get a prize yet. Now, I'm from Holland, so I bought some Dutch prizes. So whoever gets the next one first gets this one. It was indeed HTTP. DMAP. I think it was somewhere around there. Same guy. Okay, careful. Don't hurt yourself. Okay, let's make it a little bit more difficult. And usually it gets a little bit more difficult if you put security in there. HTTPS. There you go. Okay. Another one. IMAP, I heard IMAP-S somewhere from around there. Yeah, can somebody make sure it goes to the right? Can you? Thank you. Okay, difficult one. DevOps. I heard somebody say DevOps, and I think it was. Okay, because then the other question becomes, what's this? DevOps, yeah. Is it the same guy? Okay. Helen, that one's for you, because he doesn't get two, and this is for inviting me over. I think you can only call DevOps DevOps if you actually involve security in it. And that sounds really like the moment, but it isn't. So who am I? Well, I've been introduced already. I'm the security officer for Schuberg Philis. I write some open source software. I blog a bit. And these are my contact details if you need to get in touch with me. Yeah, so DevOps and security. What's the typical reaction when you start proposing DevOps to a security guy? It's shock and horror. And there's 15 guys here who understand why, because they're the security guys, and there's more ops people and development people who go like, why is that? And well, to understand that, you have to understand that DevOps people and security people are completely different creatures, because the DevOps people come from Venus, where everybody loves each other and they talk to each other. And security people come from the planet of war, Mars. But why is that? Why that negative reaction? And let's take out the word DevOps, because it's not important what it is. But if you look at, somebody once said, if you talk about DevOps, you first have to start by defining what DevOps is. And some of the definitions go like, well, it's a methodology where development and operations work together to enable faster life cycles. It's about making more releases a day, up to 10, up to 20, up to 100 releases a day, really. With this process, software can be automatically built, delivered, and deployed in production, preferably without getting ops people involved, because, well, we have an untypical ratio here, but a typical DevOps environment ratio is 100 developers, 10 infrastructure guys, and half a security guy. That's sort of the typical setup. And it's often supported by agile development processes, and all these things raise warning marks with me. And I'm a classical security guy. And in this talk, I'm going to try and give you some ammo about how you can broach the subject of DevOps to your security people and convince them that it's actually a good idea. And to be honest, there's some parts in there that I do like. I mean, I like testing. We test all the time. So faster development cycles, when you talk to me about faster development cycles, I'm really wondering, what does that do to my security posture? And to be honest, I mean, the devs don't have a real good reputation with security people. In the OWASP Top 10 has had cross-site scripting there since 2001. 2007, cross-site scripting was number 2. 2010, cross-site scripting was number 2. And in 2010, well, cross-site scripting became a little bit less of a big problem, but it's still number 3. I mean, this is a time span of 5 years. Have we not learned? And the internet's fragile. I mean, just a little over 2 weeks ago, we learned about the Heartbleed attack. And it affected 2/3 of all the SSL servers on the internet. And it was a small mistake implementing just about the simplest protocol part in the world. It's a ping. I give you a word, you echo the word back to me. I mean, if we can't even implement a ping right, what does that say for our ability to address the other vulnerabilities? This was introduced in their code, which was reviewed. It was reviewed for security. The OpenSSL folks are not known for their big security mistakes. Well, they are now, but up until this point they weren't. And it was introduced in code since March 2012. And then 2 weeks ago, we hear about this. And, well, probably the 15 guys who are here all lost sleep over this one. So we're worried about poorly tested code. Code that you put in production and then just blows up in your face. Is that actually avoidable? Well, I think it is. And it comes down to a lot of things. I mean, part of that answer is we need to start testing. And not just testing for functionality, not just for this is the specification, this is what we wrote the software should do. If you give it 1 and 1, it should add it up to 2. Yeah, but what if I give it 2 very large negative numbers? Will it return a large positive result? Well, I don't know, the code didn't say that, it just said add this number. So we should not just test for functionality, but also for security. And there's plenty of tools out there. And they may not be perfect, but they're better than not testing at all. Commercial tools like 45 Veracode, White Hat Sentinel, open source tools like Gauntlet, which is sort of the chaos monkey for security. It really hits the system with port scans, with exploits, with everything. Systems like BDD Security, which are behavioral testing frameworks where in human language you put in the test cases and then they are tested for security. Chaos Monkey, and you're absolutely right. Chaos Monkey, what it does, it stopped the developers at Netflix from focusing on preventing systems from going down. Because before that, they were really focused on if I do everything right, that system won't go down and I have a reliable system that I can trust on. And shifted the focus from systems will go down, if not by natural causes, Chaos Monkey will do it for you and you have to deal with it. My personal favorite, Secubus, because I wrote it, but it's also a good tool to actually incorporate in operation. And do fuzzing. Fuzzing is the act of spewing random input at your systems and making sure they don't fail from it. I worked for a company that did industrial systems way back. And one of the standard tests of the guy there was if you gave him a program, he would put it on the monitor, he would put his keyboard on his chair, and he would sit down. And he bumped up a couple of times, and then if your program didn't crash, you at least passed the first test. That wasn't in the specifications. It wasn't, but he said, yeah, well, this is an industrial environment. Stuff happens, people drop tools on keyboards, and it just shouldn't break. So what is the other thing us security folks are worried when you talk about 10 releases a day? Well, we're really worried about how can our security patches get into that stream. Because normally when we go to the product owner or we go to the guy who's in charge of the system and we say, listen, we really need this patch window because we need to do the Microsoft updates. And he goes, well, yeah, can you not do it next month because I've got this big release going and it's like half a year of functionality and I really need to get it out, I've got a deadline. Okay, well, this time we'll let you go, it's not that much. And then next month it's like, well, but we need that slot really now. Yeah, but there were bug fixes and But it's really not the case if you go for 10 releases a day, because patches just become another release. I know from companies that do continuous delivery, they don't patch their systems anymore. They just deploy the next system with the patches in there, and it just becomes a release. And if you miss a patch window, or if you miss a deployment window, there will be actually 9 others that day. So it's not that bad to delay one feature for 1/10 of a day, or maybe shift the schedule for 1/10 of a day. But it's a very big problem if you have the functionality of half a year that you want to release now, and you can't release it due to a patch window. So it's not a single shot to get it right. It's like multiple shots a day. It's like rapid machine fire in a sense. And yeah, so it's really an opportunity for security to be there. And I really encourage people who do this to actually allow their security people to also jump that queue. Other main principle that people in security often impose on their teams is separation of duties. Saying you shouldn't be able to, there you've got ops people, you've got dev people, and dev people shouldn't touch production systems. And there's really reasons for that, why we did that in the past, and it's avoidance of threats. Now, some people say that it's required for PCI audits, and people really love PCI audits. They're really crazy about them. And to be honest, there's not a security guy in the world who really believes that you're safe just because you passed the PCI DSS audit. It's a measure, it's a test you have to pass. It's like your entry exam into university. You never learn from the entry exam. You just something you have to do to get in. Sorry, that one didn't go. The other thing security people worry about is mistakes by incompetence. We're afraid that people do things they're not equipped, that they get out of their depth. That they touch a system and they go drown themselves in complexity. And does that really happen? Well, we're a DevOps shop, and we have been even before it was called DevOps. And we had DBAs and we had system administrators, and we allow system administrators to touch the database. And it's about culture. Everybody who works in a team is working for a common goal. That common goal is to keep the system alive, to keep the system performant, and to support the rate of change it needs. And if you support the rate of change it needs, then that means that if, for some mysterious reason, your Oracle database dies on you, it's okay for a system administrator to attempt to restart it. But a system administrator is clever enough and knows that it's not in the interest of the mission that he's trying to accomplish to say, look, the entire Oracle database corrupted itself. No, I can fix that. No, he'll pull in a DBA. Other way around, the DBA with us does simple system administration tasks when they come in front of him. He's not going to sit around and wait 2 weeks for a system administrator just to enlarge your file system. He's going to do that himself. On the other hand, if the Unix system completely fails and the root file system gets corrupt and the thing really goes somewhere where he doesn't understand it, he will get a system guy in. It's also about transparency. If you make sure that all changes to the system that go in are actually visible, peer-reviewed, and are small and understandable, then the DBA goes, yeah, you fixed that problem, that's how I would have done it, or, well, he fixed it in a way I wouldn't have done it, let me correct that. So you get a system that's more resilient to the things that happen around it, instead of trying to avoid it. And to be honest, I mean, it's a public secret that not every part of your system is actually either in scope of PCI DSS or SOX or whatever other standard. It's usually small parts of the system that are in scope. So why not put approval workflows around changing those steps? The other reason for doing this is fraud. And there might actually be cases where if people work together, there's financial loss. There's usually more financial loss by stupidity, by the way. But if you're worried about inside threat, that's a valid reason. And again, it's about transparency. Make sure that the only way to change the system is to actually change it through the configuration management system. to make sure those changes are visible, they are peer-reviewed, they are small and understandable and not a big blob of change where you can hide your malicious code in. And again, not every part of the code is in scope of these systems because not every part of your system is actually fraud sensitive. And a way to do that, for instance, is to put digital signatures on critical code. So if somebody goes in and checks in critical code that has changed, it will fail the signature because the code has changed. So the build fails, known to us as Jenkins says no. And then the security team can come in and actually review that code, saying, yeah, the change you made was okay, reapply the digital signature, and it builds okay. And actually the good thing is that this will create a feedback loop where people start to become sensitive and say, listen, I'm changing a critical part of the code. Let me get security involved in and ahead and really start that discussion before I check it in and before Jenkins actually breaks the build, because I don't want to be the guy that breaks the build. DevOps is about 10 releases a day. And 10 releases a day, you can't deal with that with a change advisory board anymore. Now, the change advisory board is that meeting that's held once a week in the old gym, and it's where security says you cannot have what you want. So one of the things we ask, one of the classical things we ask is that all changes are reviewed for security. And I think really, if you want to review all changes for security, and you do 10 deploys a day, this is the only method you can actually review them. So one of the things you have to explain to security, if you want to tell them on this idea, is listen, our business needs is agility. Security, you're not going to survive reviewing 10 changes, 10 releases a day. That's 50 changes a week. You don't have the capacity as a security department to review all those changes. So for development and operations, it's a good opportunity to say, okay, let us help you in dealing with this volume of change. Can security help development and operations to understand which changes need to be brought to them for review and which changes don't need to be brought to them for review? Again, implementing those signatures is a good idea. Adding automated security testing is a good idea because that can be a good substitute for security reviews. The other thing we always have said is changes must have a rollback plan, which is a good idea if you're doing a few changes a year and they are nice and linear. But this is a typical deployment graph, and I don't even know where I stole it from anymore. But can anybody explain to me that if we had a change here and we're now here, and we found out that this change was wrong, how we can roll back from here to here and then replay all that? It's just not true anymore. You can't deal with rollback plans anymore. There's only fix forward. And because we've got 10 deploys a day, there's 10 chances to fix this forward. So one thing that will give us, the security tribe, a feeling of comfort is if we treat it like first-class citizens. If we're allowed to jump the queue with our security fixes, without a lot of discussion, without the whole usual, like, yeah, that's half a year of development you're delaying, you're the one that's, so. But it is more opportunity to get things fixed. So we, the security tribe, are afraid of uncontrolled change, and to be honest, we're a bit afraid to give up the cab because it was our point of influence. It was the only place where people really listened to us or were made to listen to us. So how can we reassure ourselves? How can we as a security tribe be reassured? Tell us that we are going to become the immune system. Give us insight into all changes. You shouldn't hide things from security. Give us the right to test and verify your changes however, whenever, whatever we want. If we want to pen test your system, you shouldn't be going, I don't have time for it. No, give us that right. Let us review a change. Listen to us when we come with advice, because in the end, we are after the same goal. And put in your automated test, and that's a recurring theme. The other thing is that people have to realize that pulling the Andon cord is not saying no. It's not security saying no. Now, who here is familiar with the Andon cord? Okay. The Andon cord is a cord that runs, it originates from manufacturing, where DevOps originated as well. And for instance, in the Toyota factory, every station has the Andon cord strung across it. And whenever a guy working at a station, for instance, engine assembly, assembles the engine and then passes it on to the next station, and he feels that he's passing something on to the next station that's not finished, he can pull the Andon cord and the entire production line stops. Just to allow him to finish what he's doing and then start up the line again and turn it on to the next station. Who here has any idea how often the Andon cord is pulled on average in a Toyota factory per day? And twice a day, once an hour? Once an hour is closer, but it's actually multiple times per hour. Because the Toyota engineers that looked at the factory realized that it had a bigger effect, a bigger disruptive effect on the whole system if crap is pushed to the next station, where it has to come back to be refactored. And it's a bigger disruption than shutting down the entire production line for 5 minutes, putting it up and continue business as normal. And it's not a shame. Nobody there is judged for pulling the Andon cord, because you're doing the right thing, you're making sure that the flow continues. The other thing is that we, as security tribe, we need a reminder that our survival isn't mandatory. Nobody's here to make us as a security tribe successful. They're all about the survival of the company. If we're going to be the ones to slow down the company, make it go bankrupt, we lose our jobs as well. So either we have to work, we have to adapt to the new ways and new demands of this world, or as a security tribe become extinct. Now, often DevOps is supported by agile development. And agile development, you can define something, there's different roles, but one of the roles is the product owner. And the role of the product owner is to deliver functionality to the end user. So somebody comes to the product owner and says, listen, I want this button, and if I push that button, I want my screen to go green. That's how things are worded. Or I want a shopping system where I can put bananas into a shopping cart, and they have a price, and if I put 10 bananas in, I have to pay 10 times that price. Then it gets turned into a user story. That user story gets story points, and those story points are there as a measure of how complex it is. So building a shopping cart for bananas is not very complex. And the other thing is that in agile development, you don't get points for fixing defect. So if you send that engine on to the next station and it comes back and you need to return, that's not story points. And your progress is measured, your success is measured in how many story points can you deliver. Now the thing is, security is a non-functional requirement. When that user came to you with that user story and says, I want a shopping cart where I put 10 bananas in, I pay 10 times the amount for bananas. He didn't say that if I have a shopping cart and I put minus 10 bananas in it, and this is not real shopping, this is virtual, so you can shop online for minus 10 bananas. But then security requirement is, yeah, we're not going to pay this guy for the amount of money for 10 bananas. We're not in the business of giving away money. So dealing with those constraints actually makes the story more complex. So to deliver that functionality, it now all of a sudden becomes more costly because you have to make more story points. Also, because you're not rewarded for fixing defects, you're also not rewarded for fixing security mistakes. So if there's a cross-site scripting vulnerability in there and you need to fix it, then yeah, you don't get story points for that. So devs don't like to fix security faults. And as a result, security makes you seem less agile. It's, again, security slowing us down. Now, it's actually not true if you do it right, but you have to make sure you do it right. And that means there should be a good cooperation between security and the product owner, where they say, okay, I want to go to a shopping cart. How can this go wrong? I want to do an online forum. What can go wrong? I want to introduce a functionality where people can upload their vacation pictures for a campaign. What can go wrong? Then the product owner needs to realize that non-functional requirements are requirements too. If you're building an online bank, you sort of start to lose your customers really fast if they put money on there and the next day it's not there. That's one of the cases where security can really make you go bankrupt. And dealing with those non-functional requirements from the start is actually more efficient and effective than delivering the functionality and then finding out that the non-functional requirements haven't been dealt with. Yeah, and make sure that the team, the technical debt has been mentioned before, make sure that the team is also rewarded for reducing technical debt. Because technical debt is aptly named. It's something I don't do now, so I'm borrowing time from the future. I know I have to tidy my room. I'm borrowing the time from the future. I'm not doing it now, I'm going to do it later. But if I don't do it before my mother or whoever or my wife tells me off, then I pay interest because, yeah, I both have to clean my room and I have an argument. So it's aptly named. And security debt is just another form of technical debt. So where does it fit in the agile development cycle? It fits everywhere. It's part of backlog grooming, it's part of sprint planning, it's part of executing. Security should be there for the developers to rely on, to be their mentor, their guide, their technical conscience. It should be part of your automated testing, your deployment, and it should be part of acceptance. Acceptance testing should include security testing. And then the cycle goes on, and this is a cycle that goes on every 2 weeks. Now, to be honest, as a security folks, we're misguided too. We're obsessed by locks. The bigger, the better, we think, and it's just not always true. We're not always spending our money and our effort where it has the most effect on security. And this is something that Joshua Corman pointed out to me. He said, okay, what's a good model for determining getting the best bang for our buck in terms of security? And the first part of it is defensible infrastructure. We have to start building defensible infrastructures. And this is like the story of the 3 little piglets. One made a house of straw, one made a house of wood, and one made a house of stone. Now, we can really be obsessed about how quickly a pig can run and maybe design pigs that can fly. But we don't need to do that if we build a stone house. Then it's about craftsmanship. If you have a stone house and it has 4 doors and you say all 4 doors are locked, are they indeed locked? And do you know that the sound you hear from the top actually means that the big bad wolf is now trying to climb through the chimney? And how are you going to stop that? By lighting a fire under the chimney. Then it's about situational awareness. It's listening for those sounds. It's watching around you, what's happening. How does it move? What are your adversaries doing? And then in the end, it comes down to mitigating measures. And mitigating measures are those things that deal with very specific threats. It's like, do we need spiky jaws on our bear clamp, or do we need to have just a really sharp edge so that we cut off its legs straight away? That's mitigating measures. And they're the most interesting to talk about because, yeah, you can talk attacks and scenarios, but they're not the ones that make us the most secure. The ones that make us the most secure are at the bottom of the pyramid. They're defensible infrastructure, craftsmanship, and your situational awareness. But if you look at an average conference, and I think this is the RSA conference in the US 1 year ago, almost all the talks were about mitigating measures. A bit of the talks were about situational awareness. 2 talks actually were about craftsmanship, and there was 1 talk one talk only that was about defensible infrastructure. And it was in the life track, so it was really about fundamental things. Now, how do we, an example of where we do that is at our company, my security team actually took ownership of building the base images for our cloud. So if somebody wants to deploy something in our cloud, you're not going to put the Microsoft CD in the cloud and spin up an operating system. You're going to boot from a template. We own that template. And we said, okay, infrastructure is becoming software. Let's build this as a software product. So what we built was a build street where every time Microsoft released patches, we take them in, put them through a Jenkins process, have them security tested, and in the end, we have a running security system. And for us, that's a big win, because in the past, I could go onto a system, do a few tests, and tell you who installed it. Because there was just tiny differences. If this guy installed it, it would be like that, and if that guy installed it, it would be this. And systems were like snowflakes. They were all different. Now they're all the same. It means for me that every system that gets deployed in an organization at least starts secure. It means that if we introduce a weakness into our build street, the actual images, the actual build breaks and the images don't go to production. And I can go to the auditors and say, what have you done for system hardening? Well, everything that goes into production in our cloud actually has this seal of approval on it. But there's also a win for the DevOps people. It means that they have a solid platform where they know that this is where their software needs to run. The software needs to run on this. It's not runs on my laptop becomes irrelevant. It needs to run on this. And they don't need to wait 2 hours for the Microsoft patches to actually get installed on their platform when they use it, because they can just take the latest base image and know that it's been patched. In the end, we need to go to a model that's rugged DevOps. It's not about preventing threats from happening, it's dealing with them. And if you can rebuild your system 10 times a day, just because it blew up, it's got so much advantages. Infrastructure has become code too. It can be unit tested. Security can be built into it. And it has a lot of small changes that take place often. Small windows, emergency changes can skip the queue, and the environment can be rebuilt often, which implies that you do your DR test 10 times a day. It enables easy patching, and DevOps is about quality, and security is about quality as well. So security is part of all the ways of DevOps, and this comes from Jenkins' excellent book, The Phoenix Project. If you haven't read it, put it on your reading list. But DevOps says that code that's not in production isn't code, and code that isn't secure shouldn't be code either. We should stop treating security as a silo. And obviously, if you talk about DevOps, you need to have a slide with silos on it. It's about feedback loops. I have kids. I know that if 1 week after they did something wrong, I go and tell them, they will say, yes, Daddy, I'm sorry, but they've not learned anything. To be honest, we're the same thing. If we do a security test twice a year, and after half a year we tell a security developer, listen, that code you put in, it's really not secure, or the way you harden that system is really not appropriate, he doesn't know what he's done anymore. But if you amplify the feedback loop, make it shorter, make it go quicker, he's sort of, okay, I changed something on the system, Nagios goes red, I've done something wrong. I need to be aware when I do things like this. I think experimentation. DevOps is really about experimentation. It's about the complex system. Prod, sense, and see what you did, if it actually had an effect. I think DevOps for security is the chance to actually do it right this time. Here we can go in, get it right, turn from bolt-on security to built-in security by building defensible infrastructures and appealing to the craftsmanship, and make sure that that craftsmanship includes security design. In short, I think that DevOps is full of win if we're willing to listen to each other and adopt it. Thank you.
very much, Frank. Do you have any questions on this topic?
So the question was, if PCI is mandatory to your organization, will this still work? Is that a correct? What? Will this still work if you have PCI? PCI doesn't say you can't use DevOps. PCI has a number of things that you have to have or have a very good explanation to your PCI auditor why you don't have them and how you mitigated it otherwise. So not all. Well, you can have, so with PCI, your desktop isn't in scope of PCI DSS. Your public website isn't part of PCI DSS. It's only the systems that deal with credit card numbers where you need to be capable of PCI DSS. And there you need to have something like the signatures that show that there is indeed a segregation of duties. But segregation of duties doesn't literally mean that it has to be a silo of devs and a silo of ops and a silo of security. It just says that there need to be more people involved, and the people who put in the code can't be the same people who approve the code. But that doesn't mean they have to go and sit on different planets.
Next time we will have audit. I ask you to come and explain them, your ideas. I'm not sure you are successful. Thank you.